And we're live. Ladies and gentlemen, hello and welcome. Part of the Rancher community here. My name is Robert Sirchia. I am going to be your host. And today I am excited because not only we're live, everyone knows how excited I get when we're live, but I am joined by a very esteemed colleague of mine, our guest, Rey Lejano. Rey, welcome to the show.
Thank you for having me.
All right. And Rey, what are we going to be talking about today?
We're going to talk about behind the scenes of the Kubernetes 1.25 release, which is scheduled to go out later today.
Okay, so we're going to get a behind the scenes view of what it takes for this large, I don't want to say monolith, but it is a monolith because there's so many moving pieces, there's so many people involved, and there's a lot of work. So we were talking before we went live that there's actually work that you're going to be doing even later after the show.
Absolutely.
Is that correct?
Yes. Oh, wow. Yeah. So there's lots of things that go behind the scenes of cutting a Kubernetes release. Kubernetes is the largest Golang open source project out there. So there's lots of moving parts. There's a big release team that I'll talk about as well that does all the work. Yeah. So let me just get started. Let me share my screen here.
All right. Let's bring that up. Now, if you're here and you're live and you're watching us, you're probably watching on multiple channels. Now, if you have questions, feel free to ask the question in the channel you're in. I am monitoring these, but if we don't get to your questions, don't fret. You can join us at slack.rancher.io. There's a Kubernetes channel in there. You can ask your questions there. You can hit us on Twitter or LinkedIn. We will try to get back to those questions if I miss it or we do not get to it in time, okay? So for the audience out there, that is for you. But without further ado, Rey, the floor is yours.
All right. Thank you very much. Thank you for having me. Today, I'm presenting behind the scenes of the Kubernetes 1.25 release. I'm your speaker for the day. My name is Rey Lejano. I'm a field engineer with SUSE by way of Rancher Labs. I'm also an upstream Kubernetes contributor. I was the release lead for 1.23. I'm currently the Emeritus Adviser for 1.25. Like I mentioned before, that it is scheduled to go out later today. So some topics we're going to cover. We're going to take a few steps back before we talk about the release itself. We're going to talk about how enhancements and code changes for those enhancements make it into release. So first, we need to take a look at who owns that code and who owns those enhancements. So first, we'll talk about Kubernetes Special Interest Groups, or SIGs. Then we'll talk about Kubernetes Enhancements Proposals, which is a way to propose and communicate and coordinate efforts for those features or enhancements to go into Kubernetes. And also, we'll talk about how it's tracked and how it actually gets into release. Then we'll review the release cycle itself and release day activities on how we cut a release, so like what's the efforts currently going on right now. Then we'll talk about the highlights from release 1.25, and we'll review what's new, what are the major changes in 1.25, any key removals, deprecations, what's gone to stable or GA, some key beta features, and also we'll take a look at an interesting, very cool alpha feature as well. So first, let's start off with Kubernetes Special Interest Groups. Kubernetes itself is composed of 24 special interest groups, or I'm going to call them as referred to as SIGs from now on. Each SIG is comprised of members from multiple, a good number of different companies, organizations. Some folks are also independent as well, all with the common purpose of advancing the project with respect to a specific topic. The goal of breaking up the project into these 24 SIGs, and there are some SIGs that have been archived. There's some new SIGs as well, is to enable a distributed decision structure and for code ownership as well. These SIGs allow us to break into smaller focus groups to get work done, to make these key decisions, and to help onboard new contributors. Every part of the project, from the GitHub org itself, all the different repositories, all the subdirectories, the APIs, all the tests, every single issue or PR is intended to own by a SIG. And some could be owned by multiple SIGs as well. So we'll go over the different types of SIGs and go into more of the SIGs in the next slide here. But each SIG actually also owns subprojects. So it's a way to break into smaller groups with a very specific focus on enhancement work, on code ownership, and documentation. Examples are like Kubelet is a subproject under a SIG node. There's also like the kube control or kubectl. It's owned by SIG CLI. So we'll go into more examples in the next slide here. So this is an overview of the 24 SIGs that comprise Kubernetes. We have first on the very top the project level SIGs. These support the project itself. So this is architecture, which maintains the design principles of Kubernetes, contributor experience, which improves the experience of those who are contributing upstream. Docs, documentation, which I'm also the co-chair of, which publishes the Kubernetes documentation, maintains the documentation on kubernetes.io, and also generates the reference docs as well for like the API, kubecontrol, kubeadm. Release, which we'll go into greater detail in a few minutes here, which is actually responsible of releasing Kubernetes. So we'll go into that a little bit. Testing, usability, and Kubernetes infrastructure. The horizontal level SIGs spans multiple functional areas of the project. So these are like security, CLI, auth. Then we have the vertical level SIGs, which are more focused on a very specific component or area, like networking, auto-scaling for horizontal pod autoscaler or vertical pod autoscaling, and cluster autoscaling as well. Node, which has a kubelet subproject, like I mentioned before, scheduling, storage, cloud provider, and cluster lifecycle. So I'm not going to go into great detail of every single 24 SIGs just with respect to time, but so just want to show this as an overview of all the SIGs that comprise of Kubernetes. And also, I didn't mention before, there's also working groups as well, which are meant to be temporary, which have a specific goal in mind to accomplish. So we talked about SIGs. Now we're going to talk about Kubernetes Enhancement Proposals, or KEPs. And KEPs are used to propose and communicate changes to the Kubernetes project. So from now on, I'm going to refer Kubernetes Enhancement Proposals as KEPs. They are similar to Python enhancement proposals, and a KEP is a standardized development process. The KEP allows us is the unit of work for which it would combine multiple things. It tracks the features, it tracks the effort in a single document, it tracks the product requirements. It's also the design document as well. And we'll take a look at an example in the next few slides here. It provides a common structure on how to propose a change or changes to the Kubernetes project. Ensures that the motivation is clear. It also it states the goals of the KEP. It also states the non-goals of the KEP as well. It also includes testing plans as well and graduation criteria for a KEP in order for enhancement to graduate from alpha or introduced as alpha to graduate to beta and beta to stable or GA. So just to clarify things, what is not an enhancement? CRDs are not an enhancement. Bug fixes, performance improvements, code refactor are not enhancements. So what is an enhancement, or what should be enhancements, are things that should be graduating with stages, like introduced to alpha, graduate to beta, beta to stable. Any changes to Kubernetes in a significant way, especially user-facing changes, API changes as well. And each KEP is owned by a SIG. There are some KEPs that can be owned by multiple SIGs, but there's always a primary owning SIG of a KEP. And this is how we actually track features or enhancements that will go into release. We'll talk about that in a little bit. So to create a new Kubernetes enhancement proposal, this is a very high-level overview. The first thing to do is just to communicate with the SIG. So if you want a new feature or enhancement into Kubernetes, you would first talk to the appropriate SIG. Then you might prototype it. It's optional. Then you'll assemble some folks to help contribute on the enhancements as well. And folks rotate in and out quite often as well. Then lastly, once the KEP is merged, or it doesn't actually have to be merged at this state, the SIG co-chairs can opt it in for a release. There's usually discussion within that SIG to identify which KEPs or enhancements or features that the SIG will work on and will target which release.
So if I can give you a breather there and ask the question, going back a slide, those proposals that are reviewed, are these done behind doors, or are these done in public where people can kind of listen to what some of these proposals are, being that this is an open source project?
A great question. So every SIG meeting is open to the public. They're also recorded as well and uploaded to YouTube. So you could be parts. You could listen in. could be a fly on the wall, or you could be highly involved in one of these meetings as well. So I invite everyone to join. Feel free to join any of these meetings. All the meetings are listed under the Kubernetes/community repository, and in that repository, there's a subdirectory for each SIG, and within that subdirectory for each SIG, they'll host the meeting times, and also links to the various Google groups. And those Google groups, you could just opt in to be part of that Google group, you get the invites right away. So you could get the invites into your calendar, and feel free to join any of these meetings. And everyone is very friendly, so feel free to just introduce yourself, state that you're new. A lot of these SIGs have a portion of the meeting at the very beginning for new introductions for anyone who's new and want to introduce themselves.
Awesome, thank you.
All right, continuing on. So now we have this Kubernetes enhancement proposal. Like I mentioned, it's a way to on how these features or enhancements are tracked, communicated with the project itself. Just want to do a high-level overview of one of these Kubernetes enhancement proposals. On the left here, just the README, and on the right is the kep.yaml. I'm just going to mute myself really quick here while I cough. So on the left here, I just want to briefly go over what is inside a Kubernetes enhancement proposal. Just starting off with the summary. So there's usually like a few sentences of describing what that enhancement is. Tells you the motivation, why we need this enhancement, the goals versus non-goals as well, the risk and mitigations. Then the example of the enhancements being used, and some design details as well. So it could be the feature gates, the testing plan, the graduation criteria, which I'll talk about in the 25 release as well, upgrade, downgrade strategy as well, and the production readiness review. I'll talk about that during the release part. And on the right here is the kep.yaml. So this is just metadata that is representative of what is from the README. So tell you what the latest milestone of this feature is, if it's what stage of the enhancement is. So if this one on the example on the right, this enhancement now is stable as of 1.23. You can see that it was introduced as alpha 1.19. Beta in 1.21, and stable in 1.23, and if there was any feature gates as well. So now we talked about who owns the code and the various parts of Kubernetes, how enhancements are tracked and proposed as well. So now we'll go into the release cycle itself. So SIG release is a SIG that is responsible for creating these releases. In 3 releases a year. So every minor release, for each minor release, it's every about 4 months or so. SIG release also produces patch releases, which is a release every month on the second Wednesday. It's typically a 15 weeks release cycle with 2 weeks between the release. But 1.25 is a little bit different because 1.24 was delayed. So 1.25 is a 14-week cycle. And 1.24 was a 16 or 17-week cycle as well. So this diagram here is just to show you what the release cycle looks like. Like I mentioned before, we typically release 3 times a year. Each release cycle is a 15-week cycle. And we like to have a little break. So we like to have that 2-week break between cycles as well. And we will use that time to build the next release team. So starting off here let me get my laser pointer here. Week -4 to 0, we actually start before the release cycle. We assemble the release team. And the next I'll talk about the release team as well. Release team is just a group of about 35 to 40 community members who will work on the next release cycle. Starting off at week 0, we usually have a call for enhancements, which is we're reaching out to the community for SIG leads to opt in any enhancements, to opt in their KEPs that will be parts of the release. About week 4, we have Enhancements Freeze, which means that it's frozen. Like no other enhancements or features can be opted into this release. And between week 4 and week 12, we have the code work going on. So the enhancement work is actually, or the implementation work is going on. So so week 12 is start of code freeze. So the enhancements at the code level should all be done by week 12 as well. Behind the scenes, there's also lots of work with the various subteams I'll go into in a little bit as well. So week 12 is about code freeze here. Then we have test freeze as well the week after. Also, week 12 is we usually locate that week of code freeze and to release the first beta release of the release as well. Before that was alpha releases. The first alpha release is actually when the previous release was actually cut that same day. So today we'll also cut, or later today we'll also cut 126 alpha 0. So week 12, that brings us to week 12 at code freeze. At code freeze, all the code work should be done. And so we'll start releasing one or two beta releases. Then the week after, we have a test freeze. Test freeze is when there are no more tests to be changed. And also, we also do the branch cut for the release as well. With the branch cut as well and test freeze, that same week, we will release release candidate, the first release candidate. There's usually one or two release candidates depending on the release as well. And 2 weeks after that, and then we'll actually have the release itself, and then we'll do code thaw. And after the release is done, we actually release a blog about the release, and we'll go over about that. And in the next 3 to 4 weeks, we'll have a set of feature blogs that will go out and talk about the various key enhancements about the release. So we'll go into great detail in the documentation with those feature blogs. The release cycle itself there is a team behind releasing Kubernetes. It's called the release team. The release team is a sub-project of SIG release, and the release team is responsible for the day-to-day work that occurs behind the scenes of a release. So the release team, the members vary widely. So we have release team members that are co-chairs of SIGs. We have release team members that are new contributors or students as well. There's various levels of experience as well. Some who are experienced writing code, and there's a lot of non-code contributions with joining the release team as well. So invite everyone to join a release team. There's 9 roles in a release team. So I myself have been on the release team since 118. Was the release lead for 123, and I sit out for 124, and now I'm the Emeritus Adviser for 125. So in each release team, there's a release lead who's responsible for the whole release and also coordinating all the release activities as well, and who's the ultimate accountable person for all the release tasks that's needed for the whole release cycle. The Emeritus Adviser is someone who is experienced on the release team. Most have been previous release leads as well, and they're also responsible to help onboard in the new release team as well. There's a branch manager who is a release manager for the project, who maintains the release branches, tags the releases, and helps build and package the binaries for later on today. And we'll talk about the various roles or the various like bug triage, CI signal, comms, docs, enhancements, release notes. Next few slides here. Each of these roles have shadows. Most of these shadows, there's about 4 shadows per these roles. A shadow is an apprentice. So new contributors to the project, they enter the release team as shadows, typically, and where they learn about the role. And they learn about the role. Some of those shadows later on become what we call role lead, and some with further more experience become a release lead shadow. Release lead shadows are those who have experience on the release team as well, and some become a release lead. So like I mentioned before, we talked about Kubernetes enhancement proposals and how that is a way that we track enhancements in the project. So I'm going to go into into the various roles of the release team and how that relates. First off, the enhancements team. So the enhancements team actually tracks these Kubernetes enhancement proposals, or KEPs, during the enhancements collection process, the first 4 weeks of the release. SIG co-chairs will opt their KEP or KEPs into a release cycle. And the enhancements team is responsible for tracking these enhancements to make sure that they have all the requirements, like to make sure at code freeze that all the code is merged or has been approved and appropriately as well. Like if they need an API review, to make sure that there's an API review is done. They also track via a tracking issue on the Kubernetes enhancements repo. KEPs also must have an approved production readiness review. And what that is, it's been required as of 1.21 and production readiness reviews to make sure that these enhancements or features that are being merged into Kubernetes are observable, scalable, supportable, safely operated in production, and can be disabled or rolled back just in case if there's any failures in production as well. Only once a KEP is merged into and is specifically targeted to release, then the code can actually be merged as well. So the enhancements team makes sure that all the enhancements are targeting a specific release or on schedule to make sure that they have all the requirements, to make sure that the KEP itself is up to date, to make sure that the metadata for the KEP.yaml is up to date, to make sure that all the code is merged by code freeze, to make sure that it has the proper reviews if it needs an API review as well, and also to make sure if it needs a production readiness review. There's the CI signal team, which is responsible to make sure that the quality gate for the release is high. And this team monitors end-to-end tests. So they help hunt flakes on pre-submits that might potentially block the Kubernetes master branch in the future. They monitor all the jobs in various dashboards, like you see here on the right. Went too far there on the right. So they make sure that the quality gate is high for release, make sure that there's no blocking issues or blocking a test that will prevent a release. They also provide a weekly report to all contributors as well. So CI Signal, they have their eyes glued on dashboards, and it gets very, very important, especially when we cut various releases like beta cuts or release candidate cuts. And of course, the actual release itself, that CI signal provides a clear go or no go signal for that release to be cut. Bug triage is responsible to make sure that the issues and pull requests that are targeting the specific release are dealt with in a timely fashion. So they don't work on issues or pull requests personally. They can. There are lots of folks who are part of the release team who are enhancement owners as well. So they might actually work on them, but their main role is to make sure that these issues and pull requests targeting a specific release are dealt in a timely manner. So they'll make sure they'll monitor all the bugs to make sure there's no what we call critical urgent issues or critical urgent pull requests, to make sure there's nothing open that might block a release from occurring. Documentation, make sure that all the new updates in a release, all the graduated enhancements, all the new alpha features of release are well documented. If they're not well documented, users won't know how to use those features. So as we see here, they help maintain a development branch on the K website repo. So Kubernetes.io, it's actually there's a repository behind it. It's Kubernetes/website. So they maintain the development branch for the feature release on the Kubernetes/website repo. So they also make sure that all the feature gates, like we see, are well documented. There's a feature gates page on Kubernetes.io. There's a deprecation API migration page as well, so they make sure that that is well documented as well. They also generate the API, kubeadm, and kubectl reference docs. The comms team makes sure that there is an official release blog that will be released. So that'll be released out later today. And also they coordinate feature blogs for the release as well. So 125, there's 15 feature blogs, which is the most actually ever in a release cycle, or for any Kubernetes release. That's the most feature blogs we've ever had. So the comms team did a wonderful job in coordinating that and making sure that there's appropriate writers for each of these feature blocks. So next about a month or so will all be feature blocks about various 125 new features or enhancements. They also help coordinate webinars, like the official CNCF release webinar as well. They help coordinate interviews with the release lead and with various journals and online press as well. Then release notes. Release notes, not only do they generate and edit the release note, a lot of release notes teams in the past have actually recreated and iterated on the tool that actually scrapes the GitHub pull request to create the release notes. They also help curate the major themes as well. So the release notes are found in two places. It's relnotes.kate.io. Get filter out for the release version, and also there's also change log as well. That will be there will be a link in the feature blog with the change log for the release. So now that brings us to release day activities and cutting a release. So there are some release tooling that is used that the contributors have created. It's all under GitHub. It's all open source. It's all free for everyone to look at. It's Kubernetes/release. So first is there's curl or Kubernetes release. So it's a release toolbox with several commands here. So curl announce allows us to build and announce the release. Changelog automates the lifecycle of the changelog. CVE allows us to edit or add CVE information. Curl FF is fast forward, so we could fast forward a release branch as well. Curl release, which pushes the Kubernetes release artifacts to Google Cloud Storage, and also releases staged Kubernetes version as well. There's the release notes, which is the release notes tooling, or that is used as well. And stages the new Kubernetes version here. There's also other tools. Kpromo promotes the artifacts. Qpackage creates those deb and RPM package. And one of the newer ones is Bomb, which generates a bill of materials. So part of releasing, we have release artifacts, and currently they're stored on Google Cloud Platform. There might be it might change in the near future, but that's in progress right now. But currently they're stored on Google Cloud Platform. So we have container images, we have binaries, we have tar archives, we have RPM and deb packages as well. So cutting the official release. So this is what's going on currently. So the release process actually follows two main phases: a stage and release. So a stage was what we call a mock run, and the actual release we call the no mock run. So first, we actually create a tracking issue here of creating and cutting that release. So it's all public since it's all open source. So it's in the Kubernetes Slack, which is anyone is free to join the Slack. It's also posted there. It's also posted as a GitHub issue as well. First step is take a screenshot to make sure that the CI signal is good. So we take a screenshot of test grid. Then we do a no mock run. So to make sure, so this is that dry run to stage it. Then once it's actually complete, if it's good, then we actually do the no mock run. So we have and then before the official release, we also, after the official no mock run, we promote the images here. I have examples of we always list the commands that are used as well for history and to refer to in the future as well. But after we promote the images, there is a step that is done by some folks outside the release team. This is the deb and RPM package building. So this is actually done by employees at Google. So they have to, since it's hosted in their infrastructure, they have to package the deb and RPM packages. Lastly, the announcement that the release is out. So that will come around usually in the afternoon, and then code thaw as well. So there's also more steps behind the scenes as well. Part of the release as well, we also have to change Kubernetes.io as well. So what's not listed here is the work that the docs team does. So the Kubernetes.io up to this point is version 1.24. So in a few hours, we're going to merge a development branch that folks have been contributing to, which is for 1.25. So we'll merge that branch into the main branch for Kubernetes.io, and we'll make sure, and then we'll have Netlify rebuild the website or build the website on those changes. Then the website Kubernetes.io will be updated with all the new features and enhancements that are part of the 1.25 release. So just any other questions so far, Robert, before I go into silence?
No other questions, but if you need a breather there, go ahead. You've been going strong for 20-some minutes, almost 30 minutes straight.
That's all right. All right, I'll just continue on. Feel free to ask any questions as well. So that brings us to the 1.25 release highlights. So just some overview and highlights of the 1.25 release that is currently being cut and will be out later this afternoon in my time zone, Pacific time zone. Some highlights here. The start date was May 23rd. it was actually delayed a few weeks because of the 124 release. There was Golang 118.0 issues, so we actually waited to go Golang 118.1. And the target release date is August 23rd, which is today. This 125 has 40 enhancements total. There's 13 have gone to GA or stable, 10 have graduated into beta, and 15 new alpha features as well. There's one feature that's been deprecated, which is Cluster FS plugin, and one feature has been removed, which is one of the major themes of the release. So let's go into what's new in 125. So I'm going to go into what all the stable and some key beta and one key alpha feature for the 125 release. What folks should know is that pod security policy has been removed from 125 from Kubernetes starting at 125. It's been deprecated since 1.21. So there's several reasons why, and there's actually a blog post on Kubernetes.io on why we are removing pod security policy. But pretty much to summarize it, to improve pod security policy and to improve its usability, it will introduce some breaking changes. So so the decision has been made to remove it in favor with a more friendly replacement, and that replacement has now gone to stable, which is pod security admission. Pod security admission replaces pod security policy. They have very similar names. Might be a little confusing here. Pod security is also admission controller and evaluates the pod against a predefined set of pod security standards. Pod security standards, there's 3 levels of pod security standards. One is privilege, which is open. Second is baseline, which are known privilege escalations. And 3 is restricted or hardened. So pod security admission controller will verify the pod and make sure it has the required pod security standard requirements, and it'll either admit or deny the pod from running. One of the key changes as well, you actually apply the pod security admission on a namespace wide. So that it's actually going to use labels on a namespace to enforce pod security admission. There's 3 ways to enforce it as well. There's warning, so it'll just give the user a warning message, but the pod will be created no matter what. Audit, the pod will be created no matter what, and violations will be recorded in a log. Or enforce. Enforce will reject any pods that are in violation of the pod security standard. Like I mentioned before, one of the key changes as well, it's applied namespace wide. So if you want to use pod security admission, you would add a certain level, you would apply a specific label to the namespace. One of my favorite ones is ephemeral containers going to stable. So this supports kubectl debug, which is a command which went beta in 1.23. And ephemeral containers will create a container that exists for a very short time within an existing pod. So it's going to share some of the share some of the same pod namespaces as well. So it's used for users to debug the pod if there's any issues. There are some. I kind of warn people, folks. This is also another. I don't want to call it security risk, but it is a way for folks to go into a pod as well. So I just want folks to be aware of that. So yeah, so that's just one caveat. Any questions?
Yeah, we actually have one coming up. Keep the name anonymous there, but what is the shadow process for the 1.26 release?
Okay. Yeah, so the shadow application is actually out. So it's a Google form, and I don't have the link with me right now. But if you follow the Kubernetes contributor Twitter account, if you join Kubernetes Slack, it's on the SIG release channel. If you are part of the Kubernetes dev mailing list, it was sent there as well. So the process to join the release team as a shadow, it's the first step is to fill out the application. I do want to warn folks that we do get a lot of applications and there's only a limited number of spots. So the first step is just to fill out the application. Those applications are then reviewed by the various role leads, the lead, and Emeritus Adviser. And if you're selected, then you kind of start around the first or second week of the release cycle. So that's kind of like the shadow process. So if you're interested, take a look at those communication streams that I mentioned. All right, just continuing on with ephemeral containers. It's a great way to debug your pod in case you can't do kube control exec into your pod because your container's crashed or your image lacks something they can't do. You can't exec into your container or into your pod. So ephemeral containers kube control debug allows you to debug your pod that's failing. Cgroups v2. So cgroups v2 has been stable in the Linux kernel for about 2 years or so, or more than 2 years. So Kubernetes as a project wants to support cgroups v2 in case cgroups v1 becomes deprecated in the kernel. But there's also some benefits with cgroups v2 as well, as shown here. The single unified hierarchy design in the API, safer subtree delegation to containers, and better resource allocation management. Local ephemeral storage capacity isolation goes to GA. So this sets a limit on shared resources of ephemeral storage, like empty-dir. So allows you to set that limit for pods or containers that use empty-dir. So if a pod reaches that limit on you using empty-dir, the pod will be evicted. Ephemeral inline CSI volume. So this is like empty-dir, but you could use your CSI driver or CSI plugin as well for ephemeral storage. Port ranges and network policy. This is one of my favorite ones as well. So before I wanted to list a port to allow or disallow. In the network policies, it was an array, so you actually had to list each one. So this feature allows us to use a range. So now we could use a range of ports in the network policy using the end port fields for the end of the range and using the port field for the start of the range as well. And so one of the key things or requirements for this feature to be stable, to graduate to stable, is that 4 CNI providers had to support the end port field. So Calico, Entrea, OpenShift SDN, and KubeRouter supports end port. So not all CNI plugins will support this currently, so just keep an eye on that. Core CSI migration is stable. The CSI migration has been going on for many, many releases. So one of the goals of the project is to move in-tree plugins to out-of-tree plugins. So this is the CSI version of that, to move in-tree CSI volume plugins to out-of-tree CSI drivers. So part of that as well, there's been a few plugins that have been graduated to stable as well, the GC PD and AWS PD as well. Daemon sets supporting max surge. So before 125, daemon sets allowed 2 update strategies, on delete, which only replaces the pod when they're deleted, and also rolling update, which supports min available like deployments, but not surge. So it kind of brings into parity with daemon sets and deployments of adding surge as well. What this allows is 0 downtime upgrades for daemon sets. Min ready seconds for stateful sets. So this allows us to restart or to, I'm sorry, I was thinking about another feature. So this allows us to have a min ready seconds for stateful sets, meaning that pod is considered to be ready. Otherwise, the default is 0, meaning that once a pod is up and running, it's considered ready. But if it's actually crash looping, it's actually crashing, then it'll go from ready to non-ready or crash loop back, or it'll just cycle throughout those errors. So this allows us to set a minimum ready seconds time. So this is actually worked by SIG Windows, so identify pods OS during the API server admission. So this is worked by SIG Windows, and the primary goal of this feature is to identify the OS of the pod, like Windows, at the API server admission. So it will apply the appropriate security constraints on that pod. Next, going to beta is a CRD validation expression language. So this is the ability to use a common expression language as well for CRDs. So allow us to, so that means that we don't have to add in webhooks for the CRDs, and CRDs will be more self-contained and declarative. So the rules are within that CRD object manifest. Ephemeral storage quotas goes to beta. So the goals for the ephemeral storage quotas is to improve performance by monitoring using the project quotas. So this is using file system quotas to monitor the local ephemeral storage being used as well. And this new mechanism uses the file system project quotas to allow to monitor the resource consumption. And you could also enforce limits as well. The current mechanism before 125 was slow and had high latency. Configurable grace period to probes. So this adds another field to probes, which is probe.termination grace period second, not to be confused with termination grace period second. So this field is nested under probe. So therefore, the probe.termination grace period second. This allows you to decouple those two fields. That means if there's an error, so it won't wait until termination grace period seconds to time out, which could be a very long time. So allow you to set another time limit in case a probe fails. Server-side unknown field validation. So this is when server fails an object with invalid field. Let's say you just have a typo on a field, or if you've made up a field as well, the server side will fail it. So this allows the removal of the client-side validation from kubectl, but have the same functionality. And lastly, this is one of the alpha features, even though there's many alpha features. I just want to highlight it. This one is Key Management Service Kms version 2. So this allows us this is alpha as well. So you will need to turn on feature gates. So you will this allows us to fully automate key rotation as well, improve reliability on a KMS plugin. And also, so one of the reasons why this came about is because when you started your cluster, we started your API server or Kube API server as well. It will make a list call for secrets or anything that's encrypted, which are secret or encrypted at rest, which are secrets. But when it does the list call, it might take a long time because it's serial, and you also might hit the external KMS rate limit. So you might delay the overall readiness of the cluster. And some clusters are very, very big out there, and some have many, many secrets to be used. So the goals behind using KMS v2 is to improve the readiness time for those clusters with a large number of encrypted resources, and also to prevent hitting that KMS rate limit as well. All right, so that's all the key features that I want to highlight that went to stable in 125, and went to beta, and that new alpha feature, the KMS v2. So I just want to hand it off to Robert. Here's a page here on how you can reach out to us, how you can connect to Rancher or SUSE and Rancher.
Thank you, Ray. Follow us on Twitter, LinkedIn. Join our Slack channel at slack.rancher.io. We've been working on that all day today, keeping the community members there engaged. Or if you're watching this on YouTube, like our channel or subscribe to it. If you want to go to the next slide, join Ray and Eamon are going to be doing the next Rancher Rodeo, and the link is there. We'll put that link in all of our social channels as well, promoting that out. Ray, what is Rodeo real quick before we let you go? I know you've been doing a lot of talking, but
yeah,
what someone's going to expect with this?
Yeah, so Rancher Rodeo, it's about a 3-hour workshop. So half of it is hands-on. So you actually get 2 VM or cloud instances to actually deploy a Kubernetes cluster, deploy a Rancher on top of it, and its requirements. So we actually install Helm, install Cert Manager, and you also learn about the basics of containers, Kubernetes, and some of the Rancher distributions of Kubernetes and Rancher itself. Then you'll actually get some hands-on experience with the Rancher Rodeo and deploy Kubernetes, install Helm, install Cert Manager, install Rancher using Helm, and then from Rancher you could install another Kubernetes cluster, your downstream Kubernetes cluster, and deploy some workloads we'll deploy a stateless workload, and we'll also deploy a stateful workload as well. Install a CSI driver as well. So you'll learn a lot if you don't have that much experience in Kubernetes, or even if you've had lots of experience with Kubernetes as well. So definitely great learning experience.
And it is a couple hours long, so do not feel like this is going to be you're going to learn this in 20 minutes. This is a couple hour long workshop. So if you sign up, you're there for you're I won't say you're there for the duration, but it is a long workshop, but it is well worth the time. Ray, I want to thank you very much. This was very insightful. I was answering questions people are fielding over here, but we'll see everybody else in the community. Ray, thank you again, and till next time.
All right. Thank you very much.